In this third video on the graphing the derivative function, the function f1 of x has been chosen to be x times e to the minus x. So we'll just go to page 1.4, and here it is. The graph heads off towards minus infinity as x tends towards minus infinity, and it's asymptotic to the x-axis for x is heading towards positive infinity. And at x equals 1, the gradient is 0. So that's a maximum turning point just there for the graph of our function. So we'll just take a tour back in the negative x direction, and we would expect our gradient graph to become extremely steep there. And the reason for that is fairly apparent. The tangents are steeper and steeper the further left to the left we go. So just stop there for a moment where the x is minus 1.8, the gradient is 16.9, nearly 17. So we would be plotting a y value on this graph way up here somewhere at 17. We can't even see it in this picture. So let's move our value of x to larger values. You can see there, as soon as we get to 1, the gradient is 0, so we plot 0 there on that set of axes. Moving further to the right, as the x's increase, you notice the gradient is decreasing. This is not surprising because from the red graph you can quickly see that it's heading towards 0 in gradient, although it's negative all the while. So there's the graph of that. Let's go back and change our function f. Let's change this to another interesting species of function. We'll choose mod of x minus 1 plus 2. And just have a look at this. And there it is. As we move our x down here, you can see that there's an abrupt change in the shape of the tangent and its gradient. So we'll do that again. As you head down here, the slope of course is minus 1 for this entire section of the graph along here. So as the x increases towards 1, there it is at 0.9, at 1 itself it's simply undefined, and that's borne out just here. So we increase the value of x, it hops across the other side, and all of a sudden the gradient is now plus 1. So there's been a jump in the value of the gradient. So because of that, there is no unique tangent that can be drawn in there. And if we look at the graph of the gradient function, you can see that for all values of x along this section of the hybrid, the gradient is always 1. To the left, there it is, it's minus 1 all the while. At the point x equals 1 itself, gradient function is undefined, and what that means is that we have this jump discontinuity in the gradient function. So just in there, the gradient function fails to be continuous, and what that simply means is that at that point there the function is not differentiable. So for a function, when a function is not differentiable, the gradient function is not continuous at that point.